Hi everyone, Brybone here, back with another video. Today we're going to talk about Sliver C2. Really cool newer C2 framework by Bishop Fox. It's all written in Go. Very, very cool the way that it works. It has some really interesting functionality embedded in it, like some of the pieces of the Armory. It's server clients, much like Cobalt Strike, so it's great for red teams. But yeah, it is one of the coolest frameworks I've worked with in quite a bit. So let me show you Sliver, and I'll show you some ways to detect Sliver usage in an environment, as well as a quick way to detect a Sliver beacon that hasn't been horribly obfuscated. So we're going to start here with Kali, and I have Sliver server running here. It is already running in the background, so I'll clear that out and I'll show you the jobs that I have. And this is gRPC. This is the multiplayer that you need to allow a client to connect. This is the MTLS listener, which is a beacon listener, and it's mutual TLS. That means it authenticates TLS on both sides of the connection. One side will only allow a beacon that was generated by the server to connect. And then I've got my standard HTTPS beacon listener as well. So it all depends on how you generate those beacons. So our Sliver server is ready. Now, the commands you would need to make this ready in most cases are multiplayer. So that turns on the client functionality. And you also need to do new operator like that. So you create a new operator and you give them the config to then load into their Sliver client. So quite easy to set up. You can install it with apt. So you just do apt sliver-server, apt install sliver-server on your Kali box. Same thing with sliver-client. So we've got the server going over here. Clear that out. And we're going to do our actions from the client now. So we'll just go Sliver client. And because we only have one config in here, it's automatically going to connect and let us in. And you can see it loaded aliases. We've got 83 extensions. It's using my Kali user, and it says all hackers gain. So it always says all hackers gain something. It's kind of a throwback to Magic the Gathering, which is where Sliver came from. So the term Sliver was a character in Magic the Gathering where they were invisible or couldn't be detected, which is kind of cool. All right, so in Sliver, we need to generate beacons. We need to get them installed. So the first thing you want to do when you're using Sliver is you want to generate a beacon. So you would go generate beacon like that. And then you can give it something like --MTLS. And then you give it the IP that you want. So it'd be like this, 136.37. So that's the IP of my server. And then you give it, --save, and then where you want to save it to, right? And then you get that on your host. Now, I've already generated a beacon and got an implant and a host here in my lab. And it's running in the background. It's an MTLS beacon. But that is just in the instance of time. These beacons take quite a while to generate. They're also huge. They're roughly sometimes 12 megs in size. So very, very big from a beacon perspective, and that's because it's written in Go. It's one giant monolithic file. So, but it being written in Go means it's harder to detect and harder to reverse engineer. But I'm going to give you some tricks on how to do that. So first, we'll clear out Sliver here, and we'll take a look at implants. And you can see I created a beacon, and its name is beacon. And it's an MTLS beacon on my server IP and port 8888. And it's a Windows AMD 64. The beacons from Sliver generate in 64-bit by default, not 32-bit like a lot of other beacons. So you're going to always have most likely a 64-bit beacon running from Sliver. So that's our implant. The next thing we want to check out is beacons. So if you've got a running beacon, you would open up beacons here and it will show you I've got that beacon implanted on a host in my lab here. And I've got Clint Barton is a username. And the next check-in time, it'll check in here in 4 seconds, just like any other beacon framework. So to make this interactive, though, you have to go into the beacon and then tell it to be interactive, and then it's going to generate a different number. So use, and then you type in the beginning of the ID and just tab complete. And notice it's blue right here. So with it being blue, it's not interactive. That means you can't really do anything with it. So you want to type in interactive And it's going to create an interactive session here in just a minute. So right now, if we go sessions, we don't have any, but in a second, we'll have a session. So I'll clear this out. It'll tell us when it gets a session going. It does take a period of time because the beacon has to cycle through. But while we're looking at that, let's take a look at the Armory. So this is one of the more interesting things about Sliver. So if you go Armory, just like this, if I could spell, it's going to pull down all the tools that it has from the server that can be run on the beacons. Now this is really cool because look at some of these tools. These are just simple downloads. Things like Rubius, a lot of the Sharp tools, Sharp Persist, Sharp PSExec, Sharp Hound right here if you want to get Bloodhound coming in. Whole bunch of situational tools and tools that you would use as part of the framework just built in. It's a lot like Empire in this respect, where it's got a lot of the tools that you would need right there built in. Plus, of course, you can load your own, but it also has these packs. So you can do .NET execution, all the different Sharp stuff here, pivoting, Really Up, Rubius, Certify, Sharp Dump. These are really cool. And you really just simply do Armory install. So you do Armory install, and then you tell it what you want, and it'll install that tool, which is really cool. That's easy from a C2 perspective. Cobalt Strike, not so much like that, right? You have to do browser object files or load functionality in a lot of ways that you might not already have. This has just got a lot of it built in, and they keep updating it. It's really cool. Okay, so now that we've gone through the Armory, we should have a session. Sessions. Yep, and we now have a session, so we'll go use C167. And now we know we have an interactive session because it goes red. Red is interactive, blue is not. So now if we take this, we can do ls, and it's going to tell us, hey, here's the stuff in the directory that I'm in. So we have the ability to work with the beacon now. So let's clear this out. And let's go through some things that are detectable, right? So typically, a lot of times as an attacker, you're going to want to get a shell. So if I type in shell, it's going to tell me this action is bad OPSEC. Are you an adult? Now that's funny, right? I mean, of course I'm an adult, but it will say this a lot. So when you see these things that are not OPSEC safe, it's going to say, are you an adult? You can set the system to where it is adult everywhere. I kind of like getting these prompts. That way I don't do something careless. So if I hit Y here, we're now going to get a session. It's going to give us a remote shell with the process ID of the remote shell and PowerShell, PS. So that PS means, of course, PowerShell, but we know it's PowerShell because we can do commands that we would not be able to do in cmd.exe like PS. So it is a straight PowerShell shell. Now, this has a telltale sign every time you use this. That's why they said it's not OPSEC safe, because, well, it's not OPSEC safe. If we pop over here to our host and we go to Event Viewer, and we go into the Windows PowerShell logs, we'll see a 400, a 600 series event with this interesting encoding at the end that says command output text UTF-8 encoding UTF-8. That's your Sliver beacon. If you see this, that's your Sliver beacon. Same thing with the 400 here. And I don't recommend you use the straight Windows PowerShell logs here because every time this happens, you're going to get like 5 or 6 different events that are the exact same. If you have script block logging turned on, you can do Microsoft, Windows, and PowerShell. PowerShell and operational. And in the 4104s, you'll see that same message you saw before with the console output encoding equals text UTF-8 encoding UTF-8. That is what you should write your rule on. This will happen once, not 3 times on the same event, so you don't get 3 rule fires right in a row. So that's detecting shell. Now, if we go back to Kali and we want to get out of the shell, we got to type exit. And you got to give it a few seconds here because it's closing down the session. And then you'll hit enter and you'll get your interactive session back. So we'll hit enter And it didn't work that time. Give it a few more seconds. And there we go. Now shell exited. We're back at our beacon. So we'll clear this out now. And another thing we can do when we have a beacon like this is move into system. Now you can migrate, much like you do with Metasploit, you can migrate into a different process. But what I want to do is Getsystem. So I can literally type Getsystem, much like my interpreter. And if I want to, I can give it a technique, much like my interpreter. But in this case, I just want to do straight Getsystem, right? And what I'm trying to do is escalate into NT authority. Now, if I already have admin and I can get debug proof, I should be able to do this. So I'll just hit Getsystem, and there we go. I have a beacon now that is NT authority system. So if I go to beacons, I now have a beacon that's NT authority system. And it's the same MTLS beacon. Basically, I just took the beacon that I had and it up to my process, right? So now I've got a second beacon. It's not interactive. I have to make it interactive, but it is now running as NT authority system. So on the host catching that, we need to have sysmon. Now, if you don't already have sysmon installed on your host and your network, go do that. Even if you're not sending it to SIEM, it's a great artifact in an investigation. It augments your logging. It gives you a lot of power that you would not normally have. And in this case, we would not be able to catch the Sliver beacon as easily without sysmon. So let's find our sysmon store, and we'll go into operational over here. And we're going to look for an 8 event. Create remote thread. And what we can see here is we see beacon.exe using spoolsv.exe and requesting NT authority system from our user. Now the telltale sign here is spoolsv asking for NT authority system. That doesn't happen often. And from a user account, not from a machine account. So you can create your rule to look for spoolsv on event code 8 reaching into NT authority /system. Why spoolsv? Because by default, Sliver uses spoolsv or the print spooler for its Getsystem escalation. You can give it another process, but an adversary is not going to do that by default. They're just not, right? Why would they need to? They've already got this far. So you probably wouldn't change that. But that's the Getsystem detection. Now, if I know what process is my bad one, I can now look at the network connections and, oh, look, I see beacon.exe connecting to, from my source host to a destination IP with a host name of Cali on port 8888. That's a dead giveaway. Now, I wouldn't focus on this, though, because this is harder to detect, right? And especially when you're getting into just processes talking to ports. But this would be your secondary investigation to get your beacon IP. Now, we could not do that without sysmon, so you need that installed. All right, so let's go back over to Sliver now. And we have our beacon still. We're still in our beacon that's interactive from earlier. And what I want to do now is PSExec, right? So typically an adversary is going to try to move laterally once they've gotten a hold of a host at this level. If they think they've got an admin, they would use something like PSExec. So PSExec is embedded functionality here in Sliver. So we'll do PSExec and we'll do -- profile. Now you have to build a profile ahead of time. I already built a profile called beacon. And then what I'm going to do now is I'm just going to execute this, but I'm going to give it a host name. We'll just give it 127.0.0.1 because, well, in this case, I don't want to move laterally. I just want to detect this beacon installation. If I had another system in the network where I could use cleanse account and move laterally, I would be able to do this with PSExec. But in this case, I'm just going to do 127.0.0.1. Now, this is going to generate. It takes a little bit of time, but essentially, this is a service installation implant. So we'll be looking for event ID 7045 with some telltale signs of the beacon here in just a minute. Beacon generation can sometimes take upwards of a minute because it's generating that giant, 12 meg file that it needs for the implant. You're also going to see when it generates this beacon, it uses a specific nomenclature. that nomenclature is a name underscore and then another name, right? So primitive underscore trial is our new beacon name, right? It generates that so it doesn't step on any of their beacon names. It always does a word underscore and then another word, which is another telltale sign that it could be a sliver beacon, right? If you see something bad underscore tool.exe, maybe pay attention to that. That's not that common of a naming convention. So it's trying to start the service right now, but notice it also is running from C Windows temp, and it has a random 10-character executable name. So we can see it failed, but that doesn't mean that we can't detect it, right? In a lot of cases, this would succeed, and they would have a sliver beacon implant, and it would be reaching back to your command and control now. So if we jump back over here to Win 10 host 2, we'll see a rather interesting log here in system. We'll see a 7045. So this is a new service install log. And it says a service was installed in the system. The service name is Sliver. Pretty obvious there. And it also has our C Windows temp and our random characters. Now they can change the service name. It doesn't have to be Sliver, right? It can be anything they want it to be. So what do you key in on? This. It's almost always C Windows temp and then a 10-character random name with .exe at the end. So that being said, we can now have detected 3 different methods of doing the detection for a sliver beacon. Now I want to show you one with CyberChef before we go into the SIEM rule part of this. So if we load up CyberChef, and I do regex, and I do sliver as my regex, and I change this from highlight matches to list matches. This is one of the easy ways to detect if it is a sliver beacon. If you get a hold of the executable or you drop a process out of memory, something like volatility, and you run it with this sliver as a regex, it will show up as part of the beacon. Now, the reason I did this first, notice the size of this thing. It's huge. So you can crash your browser if you don't have the recipe in there already. But notice how many times the word sliver's in here. It's a lot, right? So that tells you right there, it's a sliver beacon. Easy, quick win. All right, so let's jump over to our SIEM now, and we'll refresh our alerts view. Let me just go back into Discover real quick. And I'll go back to alerts. And you'll see we have 3 alerts, one for each of the functions that we did with the sliver beacon. Here is sliver shell. If we go to table, we go to our 4th page here, we'll see the rule, event code 4104 and PowerShell script block text file, console and output encoding and text and UTF-8 encoding. Now this is KQL. We'll go to Discover, put this in here, and we'll see this is in here 2 times because I've run it twice. But you see your 4104, and here's your event log with your console output encoding text UTF-8 : UTF-8. Possible sliver shell. You see this? Could be a sliver shell. And our next alert. So our next alert is Getsystem. So this is the sysmon alert on event code 8. And give me just 1 second here. Event code 8, you can see right here. And we'll go to the 3rd page. That might be the 4th one on this one. Yep. So we're looking for event code 8, and when log event data target image spool SV, our print spooler, and when log event data target user, NT, and authority system. So these 2 are KQL. And I did them this way because KQL is native in Elastic. There are times where we will need to do leucine for advanced regexes. That's why I'm showing you these 2 first. Now, I had to do the 3rd rule in Lucene. But as you can see here, event code 8, and here's our log, beacon.exe, spoolsv.exe, requesting NT authority system. Now, if you're going to do this in the real world, you want to make sure source user also does not contain $. That way it's not a host spooler connecting it into the authority system. You might get some false positives that way, but it certainly doesn't hurt. And our final alert is the service implant. Now, because we needed some fancy regex here, I used Lucene instead of KQL. Lucene gives us the ability to do advanced regex. So as you can see here, I've got event code 7045 and winlog event data image path, A to Z, colon. So that gives me all drive letters, Windows with capital and no capital, temp and escaped slashes, A to Z, 0 to 9, 10 characters, /.exe.star. This will grab the Sliver service implant, but we have to make sure we're in Lucene. So when you go to Discover, you need to come here, make sure your language is Lucene, and then paste it in. If it's KQL, it will not work. And make sure that when you're creating your rule, that you have it set as Lucene, or it will not work. But notice we have event ID 7045 here. Here's our log, and we're catching the random named executable and its location, and you can see here's our log. So that is how you catch some of the telltale signs of a Sliver beacon. Now, Sliver is a really cool framework. I highly recommend that you play with this, and if you're a red teamer, look at it. It's really got some useful functionality that I plan on using it in my pen tests and my red team activities when I do them. So give it a second look if you haven't looked at it already, or if you have, take a look at it again. I really think what they did with this was pretty impressive overall for one of the newer frameworks. And that's it. Thank you guys for watching. Please like and subscribe. And I'll leave you once again with Hack the Planet to Defend Better. Thank you.